Spring fans, welcome to another installment of Spring Tips. This time we're going to take a deep look at the integration with Spring Boot and Kubernetes. The journey to production is riddled with non-functional requirements that will gate our ability to get there quickly and safely. Today, production for a lot of people is Kubernetes, and with that comes many an implication about the way that we build software. Some of these implications are costly. They add unwanted complexity to our systems, to our services. They are technical debt. In this talk, we're going to look at how to use Spring Boot and Kubernetes to pay down some of that technical debt. All right, we're going to go to start.spring.io and generate a new project. We'll name the service BK. And now, of course, we have some choices to make as to which dependencies we want. I'll use Reactive Web. I'll use Lombok. I'll use the in-memory embedded H2 database. I'll add the actuator support and the reactive R2DPC SQL database abstraction. And then, satisfied with my selections, I'll generate a new project and open this up in my IDE. Okay, so this is a brand new Spring Boot application. Let's take care of the pretense at business logic here, just to have something with which to work. We're going to create a application that writes data to a database. That database is going to be customer entities, so private integer ID, private string name, and we're going to persist this to the database. So we need some we need a repository, so we're going to create one here, customer repository. And this repository will of course use reactive types because they let me repurpose the threads in my application and make it easier for me to scale in a production environment. I'm not going to get all that much into reactive programming, but certainly if you're building an application intended for the cloud and for scale, you'd be wasting money and data center resources to use anything besides reactive programming or something that takes advantage of it, like coroutines in Kotlin. Now we have a repository, and what we're going to do is we're going to write some sample data to the database when the application starts up. So let's go here. We'll say application ready event. Application ready event, go, go, go. When this starts up, we're going to take advantage of our new repository and our new entity to write some data. So CR, but of course in order to write data we need to have a database to which to write it. So I'll just go ahead and initialize my database using the database client. I'll create some SQL, var SQL equals create table customer, ID serial primary key, name varchar 255 not null. Okay, we're going to use db.sql. SQL. We want to get the results, so we'll fetch that. We'll get the rows that are returned. That's the DDL. And then we will do the names. We're going to actually write the data that's we want to create. So we're going to say flux.just. And we're going to create some names. So just people on the Spring team. So Josh, Madura, Stefan, Mark, or Yushin, and then Mark, and Olga, and Violetta, and who else? Spencer. There you go. So there's a few people on the Spring team. I'm going to take each one, turn it into a new customer, null, name, and we're going to write that to the database. So the object, the customer object, has a field, which is going to be the ID, and it's got a constructor for the name. So I'm going to take each one of these names, map it, then I'm going to write those mapped records to the database. So we'll say customer repository dot save. Okay. And finally, we're going to get all the results back. So we'll say cr.findAll, and we'll just run everything one after the other. So we'll say ddl dot then many, and then we're going to do the saving, then all, and we'll subscribe and just print out the results that come back as a result of that last operation. So there we go. There's our trivial application. Let's go ahead and start this up just to see what we're doing here. So now we've got our data in the database. Now let's go ahead and ready this application for production. One thing that we can do that will help us there is to use the Spring Boot actuator. The Spring Boot actuator are a set of managed HTTP endpoints that give us information about the state of the service. After all, who better to articulate the state of the service than the service itself? We can set up a few things by going to application.properties and configuring that we want to include all the HTTP endpoints. We want to show the health actuator endpoints details, and we want to enable Kubernetes probes. We also want this application, just tangentially, to run on port 8000. So with these details in place, let's go ahead and restart the application. Okay, there it is. So let's go to the browser and we'll open up localhost 8080, or rather 8000/actuator. And there you'll see a number of different actuator endpoints, including the beans in the application, the current caches, the health endpoint, the info endpoint, the configuration props endpoint, the environment, so you can see what environment variables are acting upon this application, the loggers, etc. There's a few things that are very interesting here in a Kubernetes environment. I particularly like the info endpoint, just in general. It's a great place to put any arbitrary data you want about the application. The info endpoint is great because you can customize it. I'm going to go ahead and create a new string that tells us where, from where the application is running. We're going to use that later. So this would be the default value, localhost, okay? And then we can have an info message that reflects that, right? So, or execution environment equals execution environment, okay? So we can have a message if we wanted there as well. You can do any arbitrary thing. One really interesting possibility is to have the build automatically contribute useful things to that info endpoint, things that you can do, things that you can use to correlate the version of the software that's running in production. This is a great thing to do in a Kubernetes environment. So I'm going to go to the build, and I'm going to configure the git commit ID build plugin. But in order to do that, I need to go to the parent and find the git commit ID plugin, git commit ID. Here we go. And I'll just need to copy and paste that definition just to opt into it. So I'll go back to my build and go to the plugins, plugin. There we go. Okay, and we don't even need the version. It's just done for me in the dependency management, or plugin management rather, in the parent build. And with that, I can automatically contribute the git version of the software, but I need to build it first. So let's go here to this, and I'll do maven, so I'll do git init, git add, git commit -m, YOLO, right? And now I'm going to do a build. Maven clean package. And you can see reflected in the output there are some properties, including git.tags, git.commit message, all that information about who built the code, etc. All that is there. So there's our application, it built, and now that we've got that, we can go to the application and restart it. And the reason that this is going to be interesting is because in the files, cd target, find iname, git.properties, we've got a file called git.properties, and that information is in a property file that's in the class path now. So at startup time, all that information, including the commit ID, the message, the short, all that kind of information that we care about, all that's now in the build itself. So if I go to the actuator and refresh the info endpoint, I've got that information here. So the info endpoint is one very useful actuator endpoint, but there are others. We can go to the actuator and we can see that there's also your health and info and env endpoints. Env is great because it shows you the environment variables that are acting upon your application. The health endpoint is very useful because it shows you all the different subsystems that may or may not fail, and if they fail, would imperil the health of your overall service. These different subsystems are, varied, but you can just imagine on any microservice, you're going to have a database and a file system and maybe a message queue and a cache. I mean, there's just so many external things that our applications depend on that without which we wouldn't be able to function. So it's good to have a single place to sort of consult that status. Kubernetes actually wants two different kinds of status. It supports two different kinds of statuses. And the first is called a readiness probe. And the actuator provides a readiness probe out of the box. So you just go readiness, and there's the data. It also provides a liveness probe. And the liveness probe is different from the readiness probe in that the readiness probe tells the container orchestrator, Kubernetes, whether the application is ready to be put into service. The liveness probe tells the container orchestrator whether the application is still alive, whether it's not sick. And so these are different life cycles, different phases, but they're very useful. So you can actually change whether this says it's live or not. You can actually publish an event. What we're going to do is we're going to create a functional reactive endpoint, server response, routes, and we're going to say that we want to create an endpoint called down, and the only thing that's going to happen is when you invoke this endpoint, you guessed it, the service will register as being down. This liveness probe will register as being down. So we're going to publish an event injecting the application context, and we'll say context, and we're going to say that the liveness state is broken. Okay, so then we're just going to return a default response with nothing in it. Now here's our application. It's going to publish this application context event to any components that are interested. We can actually listen for that event as well. So we can go here and create a new Spring Bean. @bean, application listener, availability state of change event, availability listener, turn new application listener. And here we've got a reference to the type of the base type of the events that we want to listen to. So I can print out availability change event, get resolvable type, and availability change event, get state. Okay, there's our listener. So now we'll see whenever the application becomes available or not available, and you can actually see the life cycle as the application starts up. Let's go ahead and restart this application and see what we get. All right, the application starts up. We can see the liveness state becomes correct first, but that doesn't mean it's ready to be put into production. Only after we've gotten the readiness state event do we know that we're actually accepting traffic. So this means that if you want to do any kind of cache warm-ups or anything like that, you could arguably do it here. So what does it mean when the application liveness state is down? Well, let's see. So now that the application's running, let's go ahead and mark it as down. So right now it says it's up. curl -x post http localhost 8080 Okay, go here, and now it says it's down. What does it mean when the liveness probe indicates that the application is down? Kubernetes will notice that the application is sick, and it'll shut down our container. More specifically, it's going to send a sig term signal to our pod and to our container, and then we'll have a certain time, an interval of about 30 seconds by default, in which to clean up our affairs, to finish off any existing in-flight transactions, and ready the application for graceful shutdown. Spring Boot knows about the graceful shutdown mechanism in different cloud providers, including Kubernetes. So we can configure our application to stop any new requests and to finish off any in-flight transactions in that default interval of 30 seconds. We can even customize the interval in our Spring Boot application if we decide to also then one day change it in our Kubernetes deployment. Let's go to our application and we'll configure graceful shutdown. We want graceful, and the timeout that we want to take is 30 seconds. Okay, so I'm going to gracefully shut down, and then we've got 30 seconds. Okay, now we can also take part in that shutdown logic, right? We can actually, this is not a new thing. This has been in Spring forever, right? But you can participate here. So new disposable bean, and just print out. So now in order to test what happens here, in order to see this in action, we're going to create an endpoint that will slow down, it'll produce a response very slowly. So when somebody makes a get call to slow, we're going to handle the request in this handler, and we're going to return server response.ok. So what we're going to do, we're going to provide a body, and this body will be a map.of message hello request.path variable name, and we're going to turn that into a response, a value, mono. So we'll say mono.just map. We'll say that we want this to be the return value, and it'll be a map.class as the parameter type. And there we are. There's our handler to slowly produce a response. Well, it's going to produce a response at this point. Let's actually slow it down with the delay elements. And here we'll say duration of seconds, 15 seconds. Okay, so that's a good long time to expect to wait for a response. Go ahead and run this. So now we can go to our application, slow Josh. Okay, and you can see it's spinning up here. It's just taking its sweet time. So there's hello Josh. So it took its time. Now you can see that what happened. So let's go ahead and knowing what's happening, let's go ahead and start it again. Okay, and now I'm going to shut it down. Commencing graceful shutdown, waiting. Still waiting on the browser as well. There you go. I got the response immediately, and then just a second later, or instant later, it shut down in the actual console as well. There are a lot of reasons why a pod might be killed in Kubernetes. It might just be the time, right? It might be that somebody released a new version of the software and the platform is rolling out the new one and shutting down the old ones. It might be that somebody has decided to just take an application offline. It might be that somebody's got a little trigger happy with Kubedoom, and we're starting to see the negative consequences of that. There's a lot of good reasons why, but whatever the reason, it's good that we can write software that is prepared for that eventuality. We've got an application that will do the right thing in a Kubernetes environment, but what I want to know is, how can we know when we're in a Kubernetes environment? Well, we can actually write a listener, and we can configure certain beans to be conditional on a certain cloud platform. So I'll create a bean here. And this bean will just be a listener for an application ready event, just like before. But here, we're going to say hello world from, and then we're going to inject the execution environment that we created a property for earlier. So we'll go back here, and we've got an execution environment here that we've written. And we're just going to inject that key into our Java config. Okay, and we can inject this. We can say, there we are. Simple. So now we can get this configuration from the default property file here. We can also get it as an environment variable. So if I were to go to my application and specify an environment key, execution environment equals cloud9, okay, and then run that. We should see nothing, because I forgot to also tell the application that it's running inside of Kubernetes. It would detect it if it were actually running in Kubernetes, but as we're not running locally on Kubernetes, we need to force it to act like it is. So what we'll do is we'll say main cloud platform equals Kubernetes. There we go, hello world from Cloud9. So the environment variables are one way to pass in configuration that overrides the default configuration in the application. It's very easy to create environment variables from a config map in Kubernetes. It's also easy to mount a config map as a volume in Kubernetes. So we can prepare for that by telling our application to import configuration. So spring config import equals config tree, and let's say I want to run it on my local machine, desktop config. I can now create a config tree style structure here. cd desktop config echo execution environment. We're going to say the cloud. Okay, cat. There's that. So now we've got this config tree imported. We're running inside of Kubernetes, and we're going to override the default config tree. And we're going to override the default execution environment string. The cloud. Okay, so we different ways of plugging in that configuration. You can also conditionally load configuration based on whether you're running inside of a particular cloud platform. So we can have a new Spring configuration property file. We can say activate on cloud platform equals Kubernetes. And here, if we're inside that cloud platform, right, then we can actually import configuration, right? We can say we want to import that configuration here. But otherwise we won't bother, so we'll just use the default. So here I'm going to say when it's running inside of Kubernetes, then import this configuration here. Okay, so config, and what we don't want to do desktop, we want to just do /config, because that's what we're going to have inside of our pod later on, inside of our container, is a volume that's mounted at /config. Now we've got our application. We know it will work and do the right thing in production. We've got Kubernetes-specific beans and configuration. We've also got the ability to customize different things about the application, including the lifecycle and how it responds to probes and so on. All of this means that I think we're ready to actually get this thing into production, which of course means containers. Now it definitely does not mean Docker files. Don't freak out. They're not the same thing. You can get one without the other. And that's what we're going to do. We're going to use a project called Paketo. Paketo is a implementation of build packs. Build packs take an application source code artifact, be it a Ruby on Rails application, a .jar, .war, .NET executive assembly, Go binary, etc., and turns it into a container with all the sensible defaults that you need to deploy that application into production. So we can use Paketo by itself. You can just download the pack CLI and use that to build your application. Or you could just use the Spring Boot Maven plugin. So what we're going to do is we're going to deploy the application. So let's create a little deploy script here. The first thing that we care about is a way to turn our application into a container. So let's go ahead and open up this deploy script. And we're going to use Maven. So Maven -f pom.xml clean spring boot :build-image. And this would actually get you most of what you need, but for our purposes, I'm just going to skip the tests. Nobody's got time for that right now. And we're going to do spring boot :build-image name. And here we're going to provide it a container registry name. So GCR image name equals gcr.io Bootiful bk. Okay, so there's our application name. That we don't have to manually tag it later. It'll just be ready. I can just push that directly to my container registry once it's built. Okay, so that ought to do it. Let's go ahead and try it, huh? Here we go. Now we can push this Docker image to our container registry. Docker push GCR image name latest. you can see that when we run the application, it actually runs Paketo behind the scenes. And what it's going to do is it's going to look at our application. It's going to see what kind of application it is, and it's going to see it's a Java application, and it'll pre-configure all the sensible defaults required to run a Java so-called fat jar application. So now I can actually see that in my container registry. There it is just now. So that's my new container. I can now deploy that into Kubernetes. But before I do that, I want to take our code just a step further, because what we've done is we've created a regular application that we can run. So obviously I can just run this on my local machine using Docker. So let's go here, Docker run. So there's the application, there's the container, everything's fine, but we can go one step further through the magic of build packs. See, one thing that's very common that people want to do is to turn their applications into a native image. And we have a build pack that you can use to do that as well. In order for it to work, you need to just change a few things in your code. You need to use proxy bean methods equals false. And then we need to add a dependency to our build. First, we're going to add the repositories. Then we're going to add Spring Graalvm native project, which is what is coming from those. And then finally, we need to customize the build pack configuration in the Maven plugin. All right, so really all we did was we configured the build pack and we specified BP boot native image equals true. We also added the Spring Graalvm native project to the build. The Spring Graalvm project is a way to turn our source code and our application from a jar into a native image that will start up hopefully in a much smaller amount of time and will take up tens of megabytes of RAM instead of hundreds. Now this takes a fair amount of time. This can take several minutes to do. So we're going to go ahead and run it, and we'll just fast forward, and I'll see you on the other side of that. So there's our application. It's been pushed to the repository. We can see it's right here. And you can see how much faster that was. That one started up in about a tenth of a second, a little bit more than a tenth of a second, 0.15 seconds. And it has the same amount of data, same everything. Actuator endpoints, everything else works the same. It's just now much faster. So now, and it's also going to take up a much smaller footprint at runtime. So in this video, we've looked at a few features that you can use to make your applications do the right thing in a Kubernetes environment. Obviously, we've only just begun to scratch the surface. There's a lot of things that we could and should do from here, but we'll have to leave it at that. Thank you so much for coming, and have a great day.